Let's talk about the domain and vertical asymptotes of log functions. When a is bigger than 1, your log function looks like this, with a vertical asymptote right here at x equals 0. When a is a small number between 0 and 1, your log function looks like this, with an asymptote at x equals 0. So if you're given a log function with no right-left transformation, there's just an x inside, you're always going to have a vertical asymptote at x equals 0. Now this asymptote will start moving around right or left if you have a shift left or right. Let's look at an example. Find the vertical asymptote of y equals log base 2 of x plus 7. So we know that the basic log base 2 function looks like this, with a vertical asymptote at x equals 0. So this is just our sort of like basic log base 2 of x function. Now if I add 7 to the inside here, that's going to shift my graph to the left 7. So shift left 7. And so this whole entire graph, it is moved over 7, and the asymptote also ends up having to move over 7. So we shift over 7, and the asymptote moves over to x equals negative 7. So the equation we're given, it has vertical asymptote at x equals negative 7, precisely because adding the 7 to the inside shifts the graph left 7, including the asymptote. So when you're finding vertical asymptotes of log functions, watch out for what happens inside of here and if there's a right-left shift. In fact, your asymptote is going to occur when this inside thing is equal to 0. Okay, let's talk about domain and range. Now what you're looking at is our two basic log graphs. This is for when your base is bigger than 1. We see this more often. And this is for when your base is between 0 and 1. So a small number, like 1/2, 1/3, and so on. Now let's look at the first one and talk about what the domain and range of this is. We're going to use the picture to figure out what the domain and range is using the graph. Now notice in this graph, if we're going to try to think about what the domain is, we can plug in any positive number and we get a corresponding output. So if you plug in a number here, you get an output on the graph. If you try to plug in 0, there's no corresponding output. So there's no, we cannot plug 0 in here and get an output. Same thing for all the negatives. So we can't plug in any negatives and get an output. So every single negative number to the left, there's no corresponding output to go with it. So the domain of this natural log function is all real numbers from 0 to infinity, but we don't include 0. Let's think about the range. So the range is going to be every single number on the y-axis that has a corresponding y value on this graph. So for example, if we look at this point here, we can see that there's a y value that goes with it. Now this log function, it gradually goes higher and higher and higher forever. So there's always, every single point here, if you go over to the y-axis, there's a point on the y-axis that goes with it. So essentially, every single number on the y-axis has a point on this graph that goes with it, which tells us that the range is negative infinity to infinity, or all real numbers. Similarly, the domain of the graph on the right is 0 to infinity, and the range is all real numbers, or negative infinity to infinity. Now this is useful if you want to find the domain and range of a transformation of a log function. In particular, the domain is the trickier one. When you're looking for the domain of a log function, you need to have the thing that you plug in here bigger than 0. So the thing that is plugged into the x spot, so whatever's inside the log, has to be bigger than 0. Let's do an example. find the domain and range of this function here. So for the domain, we know that whatever's on the inside of the log has to be bigger than 0. So what I'm going to do is I'm going to make 4 plus 12x bigger than 0. And I'm going to figure out what x's make that true to find the domain. So we need what gets plugged into the log to be bigger than 0. So solving for x here, I get 12x is bigger than negative 4, or x is bigger than negative 4 over 12, or x is bigger than negative 1/3. So our domain is negative 1/3 to infinity. So to find the domain of a log function, figure out what x's make the inside bigger than 0. What about the range? So for the range, let's think about this equation that we're given. Putting 4 plus 12x inside, that shifts our graph of the log base 3x function left and right and stretches it a bit. So if we look at a graph like this and imagine what would happen if we shift it left or right and then stretch it a bit, we can see that the range will still be negative infinity to infinity. So the range is just negative infinity to infinity, because doing the transformations to log base 3 of x function, it doesn't make it so that you don't have all real numbers as outputs anymore.